Hi, and welcome back to the Earth Science Classroom. We are in the Wilson Cycle video series, part of plate tectonics. And a quick recap, this is basically going to follow along from the intro Wilson Cycle video, which looks at stage one and rifting, and how this cycle was a large mechanism that connected both the continental drift theory and seafloor spreading from both Wegener and Hess, and also played off of evidence and experiments done by Vine, Matthews, and Morley on the magnetic polarity of the Earth's of the crust and the Earth's magnetic field. So we're at stage two now. Stage two is called continental drift and seafloor spreading. So the rifting happened. The rifting occurred, the gravens formed, and this basin that has been created by the forcing apart of that once stable supercontinent or craton by the asthenosphere uprising is now growing. It's growing larger and larger and larger and wider, forming a new ocean basin. So this could be the Atlantic Ocean, which started to form around 180 million years ago with the split of South America and Africa first, and then later on, about 150 to 135 million years ago, was a split of North America and Africa. So there was a sequential, over a long period of time, split and formation of the newly born Atlantic Ocean. But before there was the Atlantic and before there was Pangaea, there was the closing of an ancient ocean. It was called Iapetus, which is spelt Iapetus. And fun fact, this name Iapetus comes from the Greek mythology. Iapetus was the father of Atlas, and Atlas was the Greek god assigned to hold up the heavens and the skies. That's classic statue of this Greek god holding up the spherical earth or heavens on his shoulders. So Iapetus was the father of Atlas. So fun fact, and Iapetus was basically between Greenland and Scotland, basically that small strip of ocean between those ancient land masses, and it was pretty much between 400 million years ago up to the closing point of 300 million years ago. So there's different oceans. The Atlantic is the most recent, we all know, but Iapetus was an ancient ocean that closed and formed a collision between ancient Greenland, North America, to ancient Europe, and caused a very large orogeny, which was the central Pangaean mountains, which Wegener used as evidence in terms of the rock ages and composition and faulting to use as one of his 5 bits of evidence for his book. So now we fast forward a few million years, perhaps, the consistent point here where we have the rifting and the constant spreading center. So maybe there would be a ridge right here that Hess found, but you have this mature ocean basin that has grown and widened with the spreading center, with the continental drift, so that lithospheric plate that carries the crust, be it the brand new ocean crust and the older ancient continental crust. So now we're starting to see why the continents are a lot older. Oldest is 3.8 billion years old, whereas the ocean crust usually gets about 180 million years and then starts to subduct at the active margins. So it doesn't get to the point where it can be that old compared to a continental crust. So you have this ridge, perhaps, which signifies where the upland is and the spreading center is, and the mid-ocean ridges are a great example of this, and we use the Atlantic as the example because Hess saw the Atlantic plus the Pacific, and you have this mature ocean basin, and this is stage 2 basically. So it's a larger portion than just the stage 1 rifting. All right, so stage 3 is called closure and subduction. So also you can figure out what happens here is that the ocean basin is matured, it has spread to a great width, Atlantic Ocean, 2,000-3,000 miles wide, with the mid-ocean ridge right smack in the middle. And you have these convection currents. Now, the convection currents will dictate the direction and the speed of the above lying crust of the sphere plate. We can see even, we start on the plate right here. And what you have is I've drawn this directional, this subsidence, this downward motion of the crust and lithosphere, indicating a subduction area. Now, subduction means to go under. To go under something. Now, in this case, the subduction can be created by a difference in density. If the ocean crust usually is basalt, is denser, so the average density is 3.0 grams per centimeter cubed, and it widens enough that it gets to a point where it starts to collide or have a collision, a convergent boundary, which would be right here, convergent boundary, whereby it's denser, heavier, and it's going to subduct under the lighter one it's meeting. And the same thing over here. Or it could be hitting a different kind of crust, which is mostly going to be continental, and that would be a lot thicker and lighter, and that's going to float and also cause subduction. So it happens in various situations based on density, thickness, composition of the crust, and also the speed of which it's moving. So also happens over a long period of time. So this is stage 3. And what's going to happen once it starts to subduct, then the ocean basin, the ocean width, it kind of stops growing. There is some sort of equilibrium or balance that is attained by the birth of new crustal plates here at the ridge, and the death of the crustal plates, the crustal rock, as it subducts down deeper. Now it gets down to about 150 kilometers, which is in the low velocity zone in the asthenosphere down here. And this is where the subducting cold slab, we call it a slab, as it subducts, is going to release a lot of the water molecules that it gets from the ocean that's above it, and it's going to lower the melting point and allow the solid rock to start to partially melt and go over that solidus line and produce melt and magma that would eventually form some sort of volcanism on the surface of the crust. So again, very nice symmetry, very nice mechanism to the growth of the ocean and eventually the death of the ocean crust. So now we're on to stage 4, which is continental collision. So what's happened is there has been the removal or the movement of the asthenospheric uprising. So there's no more uprising, as you can see. What you're looking at are the convection currents that are basically converging. So we have a convergence or coming together of the convection currents, thus bringing with them, the continental crust moving towards each other. So you have a towards each other situation, and eventually you're going to get a collision of two continents that's going to have this ocean that is going to progressively get smaller okay, and narrower. And you're going to have this subduction zone on either side, or just one side, but this is probably easier just to show both sides, that happens simultaneously, concurrently, and over time, this ocean's going to get smaller and smaller and smaller, and you're going to have a collision. So what happens is, the cool thing is that this is what happened with the subcontinent of India, broke away from Antarctica and Gondwana, and slowly but surely made its way up through the now known Indian Ocean, up towards the equator, and it smashed into Eurasia, creating the orogeny that we know of as the Himalayan mountains. And the cool thing is that the Eurasian bloc basically was strong, and it made India kind of crumple, and that formed fold mountains and orogeny forming the Himalayan mountains, and the Tetra Sea, which was, historically, there between Eurasia and Gondwana and India, the subcontinent of India kind of went through that ancient ocean and closed it up. And the part between India and Eurasia, as it came together, these sediments that were on the ocean floor, these sedimentary strata, limestone and sandstone, were then pushed up as the Himalayan mountain orogeny was forming, and actually layered into Mount Everest. So Mount Everest is, currently the highest altitude, highest elevation point on the Earth, 29,000 feet roughly. But however, at that altitude, you get layers of limestone and sandstone, basically transported ancient ocean floor up basically 5 miles into the air. And we know that these sedimentary rocks can only be formed at the bottom of an ocean environment. So this ancient ocean floor has been transported up to the top of Everest during this India-Eurasia collision and the closing of the ancient ocean in stage 4 of the Wilson cycle. Guys, I hope you enjoyed this video, all the 4 stages. I'm going to do a video on active and passive margins, and look at the different boundaries, especially active boundaries, in much more detail.